Hello, today I'm here to show you about my project comparing REST architecture and the SOAP protocol. To do this, I'll be using Mono XSP4 to run the SOAP server, so like C Sharp, and then Node.js Express or JavaScript to run the REST server. So my goals with this project were to test the differences between SOAP and REST at different loads. I wanted to test what levels each could be sustained at without failing or fault. So, ramping up the load from a lower arrival rate to a higher or aggressively high arrival rate. Um, the very highest percentile rate that I did was almost a bit ridiculous. Some could say, or some could say that it wasn't at all. But I just wanted to see how the different loads were handled in how the data was different at each affected speed. So, to try different data types at different speeds. Um, because, different data types, whether it be a string or integer, you're sending different levels of bytes and bits um, back and forth. So, they're going to be variable lengths, which will affect the speed, of course. So, the setup for my environment was using Node.js Express to test the REST architecture. I did it just by making a app on, local host using Docker and Docker Compose. So I did made a Node server with, again, as like I just said, Express put in there. For the SOAP server, I used Mono. Made a ASMX file, which then I built to a WSDL. The Mono server was running also within a Docker container to allow for ease of just running, C Sharp on a not Windows machine. To test it, I used a program called Artillery, which can be installed with the Node Package Manager as well. It is a really cool cloud-based architecture, or cloud-native architecture, sorry, load tester. It can be used to really load test different types of servers at any type, HTTP, sockets, RMI, and it's really nice. You can write the tester or the test script in a YAML file or YML, whichever you prefer, I guess, and you can configure it in all different types of ways. I'll show an example of that later on here. You can configure it to really sustain a load, ramp up a load, and do loads of different types, and it will output it in a nice JSON format, which can then be switched out to a HTML report, which I will show examples of here more near the end of the presentation. Docker and Docker Compose were used, and they do just speed up the process and allow for just faster ups and downs and easier modification to the servers. So the experiments, like I was saying before, were to run each server under 3 different sustained loads. The first would be at an arrival rate of 50 requests a second, which was pretty minimal. Then an arrival rate of 250 requests a second, and then finally an arrival rate of 500 requests a second. So these do seem to show different highs and lows. So we want to see the min and max response time in milliseconds, along with the 99th and 95th percentile, along with the median as well, just to see how each server does under what load, and which one is overall faster and which one is overall slower. We want to see how different data types affect the speed, such as an integer, getting a string, sending an integer, sending a string, as said before. So now we're going to hop into an example and the full reports. If we hop over here, we can see that there is, in fact, a SOAP server running. So you can look here at the .yml file to see that there is the target right here, which is the localhost 80, the server. So you can set different environments here, which I have one set for C# and one for JavaScript. This is just an example script, so it'll run a duration of 20 seconds at arrival rate of 50. The scenarios here will be a send int, send string, get int, get string, which is doing a post sending one, a post just sending the word string, and then a get of both. So if I go and run it here, it'll run for 20 seconds and output the file. This really just allows, this is just an example. I did mine for duration of 60 seconds for each rate. I just wanted to use this as an example to show the different levels. You'll show you the fails, you can get the different percentiles, and it kind of outputs in a really nice layout here. So you can see if you look at the CPU usage starts to ramp up. And you can see now that the phase is completed, and it saves it to a JSON file, which is very nice. So off of that, we can go here and look at the arrival rate differences between the REST and the SOAP. So you can see here that REST had a high maximum, very similar to SOAP, actually higher than SOAP at about 23 versus SOAP at 15. But the 99th and 95th percentile were lower along with the median. You see the same thing, at each actually, or more even not, because the SOAP is always higher in the median and 99th, but SOAP actually becomes higher in the max as well via the min. The minimum is always 0 across them all, so they do have good beginning rates, but the arrival rate really starts to ramp up with SOAP, with the more requests you start to give it, with the 99th and 95th percentile just being high, here being at 20, here being at 35, almost double that of REST with SOAP on the right. Then you start getting to 500, and REST really just takes over from SOAP here, because the REST arrival rate, we still have a high rate on some of these maximums because some requests just take a while. So with that 95th, 99th percentile, you're looking at some higher in the hundreds there. But SOAP, you're looking at the thousands, and that really comes down to quite a few failed with SOAP. So we start getting to those really high request rates or arrival rates, the requests started to fail with SOAP. So you did have about 30,000 requests being sent, but with the REST, every single one made it through, while SOAP in the 10,000s did start to fail. So you do have a really high maximum there, and a really high 95th and 99th percentile, along with the median, which can probably be skewed by the maximum. If we go and look at some of the reports here, we can see the min report with JavaScript. We have 0 fails in the bottom here. We have about 3,000 responses. The times are all there. We have this is the exact same graph we were just seeing. But if we look here, we can see that the integers and the strings are not too bad here. At a very variable time of 120 milliseconds max. But now you start to get down to the C# minimum report here. There's still 0 fails, but when you start to get to the integer and string here, there's just no contention. Really, you're even the first 10 with the string, you're very high compared to the lows here of 20 milliseconds with REST. SOAP is more consistent at those heights, but it is just the sends and gets are just so much higher than REST, in beginning at least. Now we start to get to these mid reports here, and you can see that still none are failing, but we're at about 15,000. And you can see that it just kind of goes to show that getting string, we're getting to really like 500 milliseconds here for the first 10 seconds there, and we're getting a consistent high response time, high millisecond response time with JavaScript there. But when you get down to C#, you're seeing that, or the SOAP, sorry, you're starting to see some response times, very similar, which is almost to be expected, as they are both good sustainable protocols. But they're just they're both under load, but they're both working. Now, if we get to JavaScript, we'll start to see with the there's max of 500 milliseconds or 500 requests. There's 0 fails, but there are some high numbers here. High maximums and high percentiles in the 95th and 99th. But comparatively, it is significantly better. We start to get down to the integers and the strings here. We'll see that we're at 1,200, which is a lot. But when we get to C#, we're seeing that there are a significant amount of fails with the server just being overloaded. So with that, we're going to start seeing very high maximums there. Almost in the 10,000s. Same with the 99th and 95th percentile. The median 1,700 versus the median with here, which is still 6, with REST, which really could just come down to the fails. When we start to look here at the getting integers and stuff and such, we're looking at 12,000, 1,200. The performance can be very similar with the medians of these, or the averages, I guess, of these sends and gets, but really the overalls are just significantly higher with C# and with JavaScript, or sorry, with the REST and the SOAP. My apologies. Which really comes down to show that as we see, the numbers are the data is affected by the speed. The SOAP really just can't handle these large, not only by the speed, but these large levels of load. Sorry, The REST can very easily handle these large loads, though the response time will fall back. It won't drop any requests. SOAP does seem to drop requests, and just the overall slower in most ways. Even looking at the median versus the minimum and maximum there. Even if we go to the mid report here as well, the median there is just it's not anything similar to REST, which is just significantly lower. The median here with REST is 1, while with SOAP it's 8.9. It's almost 8 times more. And you can see with the 99th percentile and all these other things, it is just significantly higher and with more fails. So really, the thing this goes to show and gives the conclusion that REST is just faster than SOAP. SOAP is nice in certain circumstances where you do want more connectability and you don't want to have to use and rely on an HTTP request. But really, if you have the option between the two, REST is going to be what makes it better for you. Also, as it just gives you so many more options with less of a WSDL and an XML based format, less having to be sent, and just really more options for a wider spread of ways to send the request, I guess. So that'll be about all for my presentation. Hopefully it was informative. And really these graphs just, I could have included them in the display there, but they really just highlight nicely with all the differences there of how a string and an integer do affect it heavily, and they affect it with SOAP versus REST, but REST can just handle those string sends and receives so much better than SOAP. It's just so much less data to send a string over with the REST architecture versus the SOAP protocol. Thank you so much for listening, and I hope you enjoyed. Thank you.